rows. Take too long to do it, too big a piece of paper. Now, the number of columns, there's really not a specific way to determine the number of columns. I do use some basic procedures. I first of all determine the number of rows based on the number of component statements. Then I list the component statements alphabetically from left to right on the top row. So if I have a P, like I did in this statement up here, I'd put P, Q, R, S, T, and U. Okay? Then I look to see if any of the individual components are negated. So in this case, R is negated and T is negated. So I'd have P, Q, R, S, T. The negation of R and the negation of T would each need a column. Then what I do is I go and look for parts that are in parentheses. So P and Q or not R, I would make a column for that. S or not T, S or not T, and U would have a column, and then finally a column. This would be the main connective. Okay, and then you want to fill in the truth values of the component statements. So if you have 8 rows, you're going to start with 4 true and then 4 false. Then you go by 2s. Each time you divide by 2, 2 true, 2 false, 2 true, 2 false. And then if you would want to alternate true, false, and so forth all the way down until you have 8 of them. If you had 16 rows, you'd have 8 true, 8 false. Then you'd go by 4s. You're going to divide in half. 4 true, 4 false. Then you're going to divide that in half. 2 true, 2 false, 2 true, 2 false, and so forth until you have all 16. And then you want to alternate true, false, all the way down again until you have 16. So that's basically how you fill in your truth values. And then you go through and complete the table. So what we're going to do is try this one, P and not Q or R. The first thing I note is 1, 2, 3 different component statements. That means I'm going to need 8 rows. So P, Q, and R. And so I need 4 true and 4 false. Since we're 8, you want to divide it in half. Okay, then divide 4 by 2 and you get 2. So 2 true, 2 false, 2 true, 2 false. And then finally we're going to alternate true, false all the way down. Okay, so that's taking care of the setup of the rows. Now, what about columns? Well, I need to look. The only one that's negated is the not Q. And then I have one a part in parentheses I need to take care of. And then last of all, I need to take care of P and not Q or R. Okay, so when I'm negating Q, I'm looking at the Q column here, and I want to negate each one. The negation of true is false. Negation of false is true. Negation of true is false. Negation of false is true. Now what I want to do is I want to look at, and I'm going to try to highlight these to point them out. Let me use blue. I want P and not Q. Join my and. Okay, so I have true and false. Remember, for it to be true, both parts have to be true. True and false would be false. True and true. True and true. False and false. False and true. Okay, so we only have 2 cases that are true. Now, in our last column, what we want to look at is this column, or R. So we're joining these with or. And it looks like it's not going to write there, so I'll write it up there. Okay. So we're joining those two with or. Remember, with or, it's only false if both parts are false. So true or false would be true. False or false would be false. True or true. False or true. True or false. False or false would be false. True or true is true, and then false or false is false. Okay, so that's the way we go about constructing our truth tables. Alright, the last part, we're dealing with what are called equivalent statements. We say two statements are equivalent, and this is our symbol, the 3 lines. If, when we construct our truth tables for the two statements, we get the same pattern of true and false in the final column of the table. If not, then the items are not equivalent. So, and for some reason this didn't copy, and I'm not sure I'm going to get this in the same order, but that's okay. These two are De Morgan's laws. They do produce equivalent statements, and I want to show you how to prove statements are equivalent by working on a truth table for each one of these. And I'm just actually going to do the first law that I have listed on my sheet. So it's only going to be 4 rows. I need P or Q, and then a negation of P or Q. And the second table is going to look very similar, except this time I need a not P, not Q, and I need a not P and not Q. Okay, with 4 rows we're going to have 2 true and 2 false, and then alternate. True or true is true, true or false is true, false or true is true, false or false is false. Negating that, we get a false, 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 true. Okay, we're going to have 2 true and then 2 false. Alternate. Negating, we'll have false, false, true, true, false, true, false, true. Okay, joining these with an and, we're going to get a false. False and true would be false. True and false would be false, and true would be true. So what I look at is this very last column, and notice how it matches. So I have proved this very first law, that those two are equivalent statements. Okay, the next thing you want to do is watch the sample problems.